Good afternoon. Today I will speak about Perl 5. So I just have to tell you a little bit of my work activity, although I have to keep silence on some of the details. I'm a freelance consultant, or I was a freelance consultant for a major telecommunication operator in France. I stopped doing that about a year ago when I got finally hired as an employee, but that's for personal reasons, health and other things. But I was working as a freelance consultant, actually as a very senior consultant. The place where I was working on data quality. So what we were doing essentially, I mean, there's a lot of activities in that, but the main point is that we were trying to ensure that the various information systems of the client, of the operator, were in sync. And for some reason, they always get out of sync after a few weeks of working. So you have one database where the client has this and that properties or attributes, and in another database, it has other attributes, and our work is to make sure that they get back to synchronicity. So we're looking for differences, and we're producing files or other means to fix data discrepancies. We have very large data volumes. The telecommunication operator has 35 million clients, customers in their database, and each customer has a lot of attributes, and so there are many things to do that. There are about 70 to 80 different information systems, and we are just maintaining the quality between all of these. So large data volumes, hundreds of millions of records, sometimes more than that. Typically, the files that we're producing are 4 to 16 gigabytes, but sometimes it can be larger. So this is now just a true story that happened 3 or 4 years ago. We were comparing the data of two applications. So I will not give the name. One is called A, and the other one is called F. A is the main business application of the operator. It actually, at least as far as mobile telephone is concerned, it is managing many things. That includes customer management, ticket rating, billing, collections of debts, and so on. Accounting, at least, accounting. F is a specialized helper application which is managing only a small part of the thing, which have to do with data over the mobile phone. So it's much more limited than A, which is doing pretty much everything. 35 million customers, and the thing that we had was extracting CSV file from each of the two databases and then comparing the CSV file. However, there was one requirement which was very important, which is we needed to convert the data from the business concepts of the A application into the business concept, i.e. tariff plans, of the F application, so that we could make the comparison afterwards. And then another thing that was needed is we needed to use a proprietary language, which I will name G, for extracting the data on A. The A application is on a very old system. It's VMS. It's using a proprietary software, and especially a proprietary language. As it happens, so this G language, I'm probably one of the 5 top experts in the world, but there are about only 50 people using it, so it's not a major accomplishment. G is somewhat similar to what you would do with PLSQL on an Oracle database. Now, here comes the problem. In order to convert the business concept of A into the business concept of of F, we have a conversion, what they call conversion matrix. Basically a table which says, well, this type of billing service on A correspond to this type of tariff plans on F. This conversion matrix at the time had about 17,000 lines. The problem is that the conversion was very complicated. It was not like a one-to-one thing, you know, this billing service is becoming this tariff plan. It's much more complicated. So basically, we're matching one or two business billing services among 30 or 40 for one client into one tariff plan on the other application. Then there's another concept, which is a business segment. Then there's a platform coming in. So, and also the matrix record may sometimes be completely filled and sometimes be empty, so that you would only match part of the data. At the end, when you go through the matrix, you may have a dozen or so records that have matched. So we still have to figure out which one is the right one, and for that there is a priority list. So this is a very simplified example. So on the left we have the priority. Next column we have the tariff plan on the F application, and then the rest of the columns are for the A application. So we have the platform that's okay, that doesn't, maybe I could have actually removed it, would have made it a bit simpler, but it doesn't matter. Then we have the business segment, which is always, there can be only one business segment for one client, so this is easy. And then we have the billing services. As I said, each client on the A application has 20, 30, sometimes 40 billing services, and we have to check every pair of billing services together with the business segment and together with the platform to see if we find a tariff on the other platform, on the F platform. And that is quite a problem. Yeah, that's what I said. So for each customer, we need, that's a basic algorithm. We need to find the business segment. That's unique, no big deal. It takes a bit of time, but it's okay. We have to find a list of the active billing services, 20 to 30 typically. And then we have to test each pair of billing services and also each billing service individually to see if they match something in the matrix together with the segment. And then find the priority, but that's okay. So we have a combinational explosion there. The program was very, 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 very slow. Actually, the original program, when I was asked to try to improve it, would have run in 160 days. Now, this type of comparisons we do once a month. If it lasts 2 days, we can still live with that because we do it once a month. If we make a correction after 3 days, it's more or less okay. I mean, sure, the sooner the better, but sometimes it takes that long. Sometimes we have some of those comparisons which take 2 days, but 3 days, maybe even up to 5 days, but 160 days, certainly not. So I made a first run of improvement of the G program. And I made an improvement which would have taken 60 days. So this is a huge improvement, but certainly not sufficient. Now I needed to know what else I could do to improve the program, and that was quite difficult. So the first thing I did is I used Perl 5 to write a profiling program for the G program. So it's actually fairly easy, fairly simple. What the Perl program was doing is to read the source code of the G program, parse what it needed to parse, and then add time recording statements before and after each procedure call, so that I would know at the end how much time it spent in this procedure call, how much time in this procedure call, adding the value each time. Then once I have modified the source code of the G program, I recompile it and run it on 10,000 or 20,000 customers to see what's going on. And the result was very clear. It spent more than 99% of the time in traversing the conversion metrics. So that's where the problem was. I had actually improved other places, also some things in the conversion metrics. But anything that needed to do was, of course, in using the conversion metrics. And I was short of ideas on how I could do that in the G program. I had basically done every trick in the book that I knew, and I didn't know what to do next. So basically, I said that the program would have run in about 60 days, so that was 59.5 days in the conversion matrix and 12 hours in the rest of the data extraction. And as I said, no further optimizing. Well, some few further optimization were thinkable, but I couldn't believe that I would get anywhere near what I needed. So we really decided to go another way. We decided to rewrite the conversion in Perl. Now, I cannot use Perl to extract the data from that database. We don't have what is called DBD driver or anything to access the database. So the extraction itself really has to be done in G. But then we do a pure, stupid extraction in G. So we just extract all the 30 billing services for each customer, plus the business segment, plus whatever we need for the thing. And we load that into a flat file, a flat CSV file. And then we reprocess this file in Perl. And the idea was to remove the sequential reads of the matrix and using the features of Perl to do that. So rewriting the conversion in Perl, and that wasn't easy because there's a lot of business logic in the program. It's actually quite complicated. But anyway, so basically, instead of having the sequential matrix, what I do at the beginning of the program is to read the matrix and store the data in a series of hashes. So basically what I had is two simple hashes for the business segment and a single business service, then two hashes of hashes, one for the business segment and one billing services, and one for the one for two business services, and finally a third, one hash of hashes for one segment and two business services leading to the priority. Then an additional array for making the link between the priority and the tariff plan. And then one auxiliary hash, which was not needed in functional terms, but turned out to be a very good idea in terms of performance. This auxiliary hash contained just a list of the business services actually existing in the matrix. Because as it turned out, each customer has about 30 business services. But in fact, only very few of them could actually be married with something in the other application. So in other words, I start with 20 to 30 billing services, and then I use this auxiliary hash as a grep to only look for those which I know I may find in the matrix, in the conversion matrix. And at the end, for most of customers, I ended up with only 2, 3, or 4 billing services. So instead of having pairs to be made between 30 billing services, I had to construct pairs only for 2, 3, or 4. So that's quite a different game. So the algorithm now is just a few hash lookups. So first, I filter the useful billing services. That's what I just indicated. You know, those which I'm likely to find in the conversion matrix. Then I look for a business segment alone. I get a priority if I find something. Then I look for each billing service individually. I get another priority. Then I look for a business service with a business segment. Then I look for each pair of business service with a segment, and so on. At the end, I keep the combination with the highest priority, and this gives me the tariff plan in the F application terminology. Now, the overall runtime, first the extraction in the G programming language, and then the reprocessing in Perl was divided by 110. So in other words, instead of 60 days, it was brought down to 13 hours. Of these 13 hours, 12 hours were for the data extraction in G, and 1 hour for traversing the matrix, for making the conversion. So, in other words, the conversion itself went down from 59.5 days to 1 hour. So that's 1,400 times faster. Of course, this meant I had to change completely the algorithm. This is somewhat complex, but all in all, it was just 210 code lines, so it's not that complicated. It took me about 2 days of coding and unit testing. Then it took a while for business acceptance because we were scratching our head on a number of complicated cases, but anyway. Well, the conclusion, a good data structure can give you a huge gain on performance by allowing a much better algorithm. Perl gives a great flexibility for constructing such data structure and for using them efficiently. Now, Perl is probably slower, it's definitely slower than a compiled language, but you can get better performance if you make good use of its strengths. Remember, the G program is a compiled language, but it wasn't efficient. Perl is not compiled in that sense, but it was much more efficient. And now, if I had used another language, say C, I probably wouldn't have thought about using ashes and this type of thing. And my final word is that I converted my whole team to using Perls for many tasks. Thank you. Any question?
Yeah. I noted that you convert the priority to your affectivity, which of course only works if the mapping is 1-to-1 between priority and Fs. So you don't have double priorities.
Well, actually I gave numbers for priority, but the real thing was that the order of the matrix was a priority. So I was just giving a number corresponding to the line number in the matrix to figure out the priority, so that the lower number would be the higher priority. But because of that, there could be only one.
Yep.
Any more questions? Oh.
Yeah. Did you actually consider of converting your matrix into a G program using Perl? And running that G program, so making a program that would decide, well, oh, if I see this business case, I could go this way, that way, or that way, and thus directing the result earlier.
Well, yes, the other options that I was considering was maybe to create table in the database which would contain the matrix, so that the matrix could be accessed in a indexed way, not in a sequential way. But because of this priority thing, you wouldn't have one by one, so it looked like it was quite difficult to do. It might have been possible, I don't know. But really the Perl solution, it took me 2 days to write it, I scratched my head over it for a week before, but when I really started to write it, it really took me 2 days. No other question? Well, thank you very much.